Our next challenge is to plot our regression results. So we want to demonstrate our model, which means we're going to need to plot our independent variable, our smoking rates, along the x-axis, our dependent variable, our lung cancer death rates, along the y-axis, and then we want to plot our regression line. So we're going to pull together all of our techniques, plus include how to run a regression, and then plot this all to a new graph. So how do we do this? First, we need to plot our smoking data and our lung cancer rates. And thankfully, this time we only need one y-axis, so we can use PLT to plot everything. Let's get things set up. We'll come into Python, we'll read in our smoking data. Don't forget we're going to import statsmodels.formula.api, matplotlib.pyplot, and pandas as PD. Our x-axis data is going to be smoking data, smokers, the smokers column, and our y-axis data is going to be smoking data, age-adjusted lung cancer deaths. And we can call plt.scatter x-axis, y-axis. And if we go to the plots tab, there we go. X-axis, we have our smoking rate, and y-axis, we have our age-adjusted lung cancer deaths. We can go a step further and add X and Y-axis labels as well, along with the title. So add in plt.title, plt.ylabel, plt.xlabel, plt.grid, and we've got our base graph ready to go. Next, we need to build and run our regression model. We'll do this by calling model equals smf.ols. We'll provide our formula. We want to predict age-adjusted lung cancer deaths by smokers. And our data is going to be our smoking data. And then after that, we call .fit. Now, if we run this right now, nothing happens. We do have our model, but we need to get our regression line. How do we get our regression line? Well, it turns out our model has a property called fitted values. This contains a list of y values for each x value in our model. This is our regression line. So we're going to extract this line to a variable, and then we will call plot, and we'll pass in the fitted y values as our y-axis. So watch this. We'll get a line called fitted, set this equal to model.fittedValues, and then after plt.scatter, we'll call plt.plot x-axis and fitted. And if we run our code, we now see our regression line. So we can see how well our data fits the model. And again, just to remind ourselves, let's print out our model summary. So our adjusted R-squared for this model is 0.858. So this is, we can actually see this on the line. Our data fits this model fairly well. Now, don't forget, because we have one axis, we can create our legend without any extra code. So we can add in a plt.legend, and then we can give these scatter plots and our line plot labels. So we'll give this a label of actual. We'll give our line graph a label of predicted. And then when we run this, we see that our dots are the actual and our line is predicted. Now, this isn't the only trick that Pandas has up its sleeve. We can also get upper and lower confidence interval data and plot these lines on our graph. So this is accessible by getting our prediction and getting the summary data frame from our model. And these confidence intervals are stored in the two columns observation CI upper and observation CI lower columns. And because our summary data frame is a data frame, you could save that to a CSV and use it in other programs. So let's get our predictions. Let's get our confidence intervals and plot them. We'll set predicted equal to the result of model.getPrediction.SummaryFrame, and then our upper CI is predicted, and we're going to get the observed value confidence interval upper column. And our lower CI is predicted, observed, CI lower. Then we can do plt.plot, x-axis, upper CI, label equals confidence interval. So we plotted our upper confidence interval, and we can do the same thing for our lower confidence interval by saying lower CI. Now, it's time to customize our visual a bit. Since we have multiple lines in our plot, we might want to lower the contrast of our confidence interval lines, maybe say mark them with dashes, and then color them consistently. So remember that we can use line width, line style, color, and label to customize our plots. Let's do that now. So my upper CI, I'm going to change the color to be pink and the line style to be 2 dashes. And I'm going to do the same thing with my lower confidence interval. So I just copy pasted the code. If I run this code, you'll see that confidence interval is now displayed in my legend twice. That's because I've given the same label to both confidence intervals. I can take out one of these labels, and now I just have the same label for both my confidence intervals. All we have left to do now is save our new plot to an image file. In order to save a plot to a PNG or an image file, we need to make the following changes to our code. We assign the result of the call to plt.figure to a variable, which we've already done in our example, and then we call the savefig function on our figure and pass in our desired file name. In the code example on this slide, we're saving our plot to myplot.png, and we're going to do the same thing with our plot in our code. Let's switch back to Spider. Back in Spider, here's our call to plt.figure at the top of our file. We've assigned that to the variable fig. At the bottom of our file, we're going to type fig.savefig, and inside the function call, we'll pass in the file name. If we run our Python script, we'll see that we now have a myplot.png in our output directory. And that's it. We've now plotted our regression model to a new plot to demonstrate how well our model fits the data.